Hey, this is Mrs. Weethy here, and we are going to do Lesson 4 on using both the mole ratio and formula mass in stoichiometric calculations. Your learning goal is that you will be able to determine the moles or mass of a substance in a chemical reaction given the moles or mass of another substance. So make sure that you write that in your learning goal or at the beginning of your Lesson 4. Now, one thing I want you to do is I want you to go back to, I believe it was the beginning of Lesson 3, and I gave you a general plan. So I want you to pause this video and I want you to write down that general plan at the beginning of this Lesson 4. Okay, now that you came back from that, I'm going to write that down and review it for you. So you start with the mass of A. We can take the mass of A and we can convert the mass of A to the mole of A. And to do that, you're going to use the formula mass. Then we take the mole of A and we can convert that to the mole of B, using the mole ratio. Now that's a critical step because this is the only way we can get from one substance to another substance in a stoichiometric conversion. Then we take the mole of B and we convert that to the mass of B. So we're going to use both the mole ratio and the formula mass. If you're given the mass, we're going to start here with the mass of A. If we're asked to find the moles of your substance B, then we're going to end here. So we'll just follow those steps. So I'm going to have you keep referring to this general plan as we proceed in this lesson. Okay, let's take a look at the first problem. We want to determine the mass of sodium chloride or table salt that is produced when 1.25 moles of chlorine gas reacts vigorously with sodium. So the first thing we're going to do is ask ourselves, what do we have and what do we want to find out? So our given is 1.25 moles of chlorine. Our unknown is grams of sodium chloride. Next, we're going to write a plan. So we want to start with our given quantity, the units of our given quantity, which is moles of chlorine. And then if you look at your general plan, you're starting at moles of A. Well, what do you do for moles of A? You go to moles of B. And that's what we're going to do. We want to go from moles of chlorine to moles of sodium chloride. Remember, your given is A, your unknown is substance B. Then for moles of sodium chloride, we're going to use the formula mass to calculate the grams of sodium chloride. So you have to ask yourself, how can I go from moles to grams? What conversion factor can I use? And right now we only have two, the formula mass, which goes between grams and moles, and the mole ratio, which goes between moles of one substance and moles of another substance. Critical to know your conversion factors and the units you can convert between. Okay, now we have our plan. We can get our balanced equation. You can do the balanced equation before you get your plan. It doesn't matter as long as you have a balanced equation. And what's the importance of that? It's to get your mole ratio from those coefficients. Now we can solve. So start with your given quantity, 1.25 moles of chlorine. We're going from moles of chlorine to moles of sodium chloride. We have to use what conversion factor? That's right, your mole ratio, which from the balanced equation is 2 moles of sodium chloride over 1 mole of chlorine. Divide out your common unit, moles of chlorine, and then go from moles of chlorine and sodium chloride to grams of sodium chloride. We have to use the formula mass. Now, a hint. If you have grams in your unknown or your given or both, it doesn't matter. If you have grams, you have to find the formula mass. And I would do that first. Now I already have it done for you. But when you're problem solving, when you see grams, calculate the formula mass of that substance. Multiply by the formula mass of sodium chloride, 58.44 grams of sodium chloride over 1 mole. Divide out the common unit. And round to the correct number of sig figs, which in this case is 3. And we get 146 grams of sodium chloride. Okay, so that's the easier of the two types of problems that we're going to do. Let's take a look at another one. Alright, we have when dinitrogen pentaoxide is heated, it's going to decompose according to this balanced equation. Keep in mind, I'll never give you the balanced equation, only in these videos, so you luck out with that. Alright, this is the problem. We want to know how many moles of the dinitrogen pentaoxide were used if 210 grams of nitrogen dioxide were produced. So what do we know? We have our given, 210 grams of the nitrogen dioxide. We have our unknown, the number of moles of dinitrogen pentaoxide. Plan. We're starting with the grams of nitrogen dioxide. And what can we do with that? Well, the only thing we can do at this point is convert grams to moles using the formula mass. Now, we have moles of nitrogen dioxide. We can take that to moles of our unknown, dinitrogen pentaoxide. And then for moles of dinitrogen pentaoxide, we can convert that to grams. Oh, no, we want to stop there at moles of dinitrogen pentaoxide. I was going one step further, but that's where we want to end, at moles of dinitrogen pentaoxide. Now we can solve. Start with your given, 210 grams of nitrogen dioxide, multiply by the formula mass with moles on top, 1 mole over 46.0 grams of nitrogen dioxide. And listen, you must have these units. Don't skip out, okay? You have to have the substance because you're working with two substances now. So you want to make sure you have mole nitrogen dioxide over 46.0 grams of nitrogen dioxide. Do that to keep it straight, otherwise you will get very confused. Divide out the common unit and then multiply by the mole ratio. 2 moles of dinitrogen pentaoxide over 4 moles of nitrogen dioxide, divide out that common unit, calculate to 3 significant figures, and you get 2.28 moles of dinitrogen pentaoxide. Okay, there's a part B to this problem. How many grams of dinitrogen pentaoxide are needed to produce 75.0 grams of oxygen? So I already have the unknown listed and the given listed. So we're going to set up our plan. What are you going to start with? Okay, good. It's grams of oxygen. And what can you convert grams of oxygen to? Moles of oxygen. And from moles of oxygen, you're going to take that to, good, moles of dinitrogen pentaoxide, and then for moles of dinitrogen pentaoxide, what are you going to convert to? Now we can take that to grams. Okay, so keep thinking of that. Even though I'm going over it and saying it and you're anticipating that, you need to keep thinking of this, the process, as we're going through this video. Now, what do you need? If you have grams in your given and grams in your unknown, what do you have to calculate first? That's right, the formula mass of both of those substances, because you're going to need them in your conversion. All right, let's solve. We are going to start with 75.0 grams of oxygen. Multiply by the formula mass with moles on top, 1 mole of oxygen over 32.0 grams. Divide out the common unit, grams of oxygen. Then multiply by the mole ratio, 2 moles of dinitrogen pentaoxide over 1 mole of oxygen. Divide out the common unit. And then finish up with the formula mass as your conversion factor with grams on top. 108 grams of dinitrogen pentaoxide over 1 mole. Divide out the common unit and calculate and round to 3 significant figures, and we get 506 grams of dinitrogen pentaoxide. Okay, so I have one more problem for us to do. And what I would like you to do is to pause the video and work out the problem first before I go through it. use this as a practice problem. So try doing it first before you watch the rest of the video. Okay, so you should be back now. Hopefully you did follow my instructions and practice the problem. So here it goes. I'm not going to say too much here. I'm just going to proceed with the video and you follow along. Hopefully you did the same thing. I feel confident that you did. Okay, now we're going to solve the problem. And the answer is 17.0 grams of aluminum chloride. Okay, that concludes lesson 4 in our unit on stoichiometry. This is Mrs. Wethy. We'll see you in class. Goodbye for now.